Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing new lesson. We have thin diverging lens, and we will differentiate between converging lenses and diverging lenses. First of all, you can find all documents and KWL charts if you join our Telegram channel. When you get your KWL chart, kindly write down here what you know about diverging lenses, what you want to know about diverging lenses, and at the end, what did you learn? And this lesson for core and extended candidates, we have some questions. Paper 1, so we will start by question number 1. The diagram showing you the path of two rays from the top of an object through a lens, and here which type of lens you have. It's already shown it's a diverging lens. How do you know? It's thinner in the center than at the edge. The object is viewed from the opposite side of the lens. How does the image compare with the object? So you can draw the rays, so you can find the location. As usual, you can follow our word lost, location, orientation, size, and type. Okay, so we have to draw rays so you can describe the image. Here we have standard rays. The first one passing through the optical center, it will be undeviated. So this light ray is common between converging and diverging lenses. Any light ray passing through the optical center will be undeviated. So this one, undeviated. Okay? Okay. The second ray is parallel to the principal axis. In case of diverging lens, it will diverge, but its extension it will diverge, but you can extend this light ray. Where the two rays intersect, this will be the location of the image. Since we have extension, so this is the image. Since we have extension, so it's virtual, and it's clear that it's diminished. It's upright, not inverted. Its location between the object and the lens. Is it clear? So the correct answer here is D. It's smaller and the same way up, which means upright. Is it clear? So we have two standard rays, and these rays will be repeated in many questions. Let's move to question 2. Okay. Question 2, we have here a parallel beam of light incident on a thin diverging lens, and we have the focal length is shown, which is FL. So this is the focus, and this is the focal length, which is the distance between the optical center and the focus. Which ray diagram showing the beam after it has passed through the lens? You have to follow the standard rays. What are the standard rays we have here? The one passing through the optical center undeviated. Let's check. So this one is okay, undeviated, but this one is converging, not diverging. Okay, this one here is diverging. Okay, so this is diverging and its extension passing through the focus, correct, but this one is incorrect. Okay, this one passing through the optical center, okay, it bends, no, so also this is not correct. So the correct one here is C, this passing through the optical center undeviated, and this one will diverge. This one will diverge, and where the extension of this one intersect or meet the first ray, this is where the image will be formed. So question 2, the answer is C. So please, you have to follow the standard rays. In case of diverging lenses, any light ray parallel to the principal axis, it will diverge, but its extension will pass through the focus, and this will be repeated in next questions. Okay, question 3. We have here a piece of paper, and we have sentence describing a process. The object is further away from the lens than the focal point, and the image is upside down. By the way, diverging lenses, the image is virtual, upright, and diminished. Wherever the location of the object, whatever the location of the object, you will find the image. It has these characteristics or these properties. So since we have here an image is upside down, which is inverted, and it's further away from the lens, so we are talking about converging lens. We are talking about converging lens. So here, the formation of a real image, do you remember we said real and inverted, they are best friends. Since the image is inverted, so it's real. Since the object is further away from the lens, and we have here upside down or inverted image, so we are talking about converging lens. So the answer is D. Is it clear? Okay, question number 4, which is challenging. Why it's challenging? Because here we didn't identify in the question the type of lens. Is it concave or convex? And by the way, converging lenses, they are called convex. Diverging lenses are called concave. Okay, which type of lens here we have in region X? So in region X here we have lens unknown. We don't know its type, but we have the light rays, the one passing through the center undeviated here, this one passing undeviated, which is common ray between converging and diverging lenses. It behaves this way, passing undeviated. The second ray parallel to the principal axis here diverge. Since the light ray diverged, so we are talking here about diverging lens. So you have to cancel, you have to exclude, you have to exclude here A, you have to exclude A and B. Okay, let's extend this ray, where the two rays intersect, you can find the location of the image. So here the image is, can you describe the image? It's upright, diminished, and virtual. Why virtual? We extend one of the two rays, so it's formed by extension of rays and it cannot be received on a screen. Is it clear? So the correct answer for question 4 is D. The image is virtual and the type of lens here is diverging. Okay, we have to remember we have standard rays we are using to draw or identify the location of the image. One which is parallel to the principal axis, and it will diverge or converge or refract. It will refract here at the center. Do you see this line at the center? This line. And many times I told you, for simplicity only, it takes place at this midline for simplicity. Okay, so what will happen to this ray which is passing parallel to the principal axis? When it enters the diverging lens, it will refract and it will diverge. But it will diverge in which direction? Okay, it should be diverged and its extension passing through the focus like this. So it will diverge let's continue in the same color. So it will diverge and its extension passing through the focus. Is it clear? So this is the first ray. What about the second ray? Passing through the optical center undeviated. Passing through the optical center undeviated. Where the two rays intersect, you can find the location of the image. Let's draw it in blue, so the location will be at C. Let me write here the fact the location of the object doesn't affect the properties of the image. Let's write it here. The location of the object doesn't affect the properties of the image. So the answer for this one is C. And let's write again one more time again here. What are the properties of the image? Whatever the location of the object, it's upright, virtual, diminished. This question is very important.
Subscribe for more videos. I love Physics Blender. I love Physics Blender. I love Physics Blender. I love Physics Blender. I love Physics Blender.